Lab-07 FM synthesis. This time going the opposite direction of the last couple of weeks. One video. That's it. You have a carrier. That's the one that comes out the speaker, usually a sine wave. Carrier into a VCA, into the Mackie, and envelope controls the volume. This is called the modulator. This is the carrier. When this is at the sub-audio rate, doo, becomes doo. When this is well into the audio rate, all kinds of other things happen. You have a modulator and a carrier. You need to control the volume of each with an envelope. Each part has 3 sections very quickly. I actually show you the patch in Modular Grid. I patch it one cable at a time. Then I quickly go into a live demo and example. This part, there will be a demo where I explain the knob settings, explain the patch, explain what's happening, and then it goes into an actual example where I quickly play something not unlike what I would expect to hear in your capture. If you do the required content correctly, you'll earn about a 75. The bonus section at the end of the video shows a number of ideas. You can use any, all, or none. And now, off we go. Lab-07. Start. Pitch output from the MIDI interface into a mult. And take one of those outputs into SSL 1200 number 2. This oscillator is the carrier. Sine wave out. This is the audio that we hear into the final VCA so that we can hear volume. At this point, if you turn this up, you should hear a sine wave and it should track the keyboard. Take the gate out, mult it. You're going to feed it to an envelope generator and then later another one. Down here. And then this to the control input. That's the entire patch for part 1. Quick knob settings. Make sure this mode switch is in position 3. That'll save you time later. Control amount, start with it all the way down. Linear switch up. These 2 switches don't matter. For the envelope generator, initial settings, 0, 0, 10, 0. The only thing is I turned the release up maybe to about 1. I liked it better. And then initial gain all the way down. Control level 1 up somewhere, wherever you want it, halfway or more, so that you hear a sine wave when you play. Then do part 1. Part 1 couldn't be simpler. Pitch CV into an oscillator, sine wave out into the VCA. If I turn the VCA up so it droned, there we go. Gate output into a mult, into an envelope generator, so I can hear the sine wave. You patch that up, tune it. And this is the carrier. Remember that. Carrier is what comes out the speaker. That's what we hear. Once this is ready, you do capture 1. That was the demo. Here's the example. You might put it into record and just do anything like. Doesn't matter what the notes are. Just play something short so I can go, check, you did a sine wave. Part 2, adding the modulator. Take the pitch from your mult into the 1 volt per octave in of this oscillator. It's all 3 spaces. Take this output, feed it directly into the CV in, not the 1 volt in. Start off with this switch at sine wave, this all the way up, 16-foot tuning, and then tune this as I showed you in the video. Then this is the patch. For part 2, we bring in another oscillator. This is going to be the modulator. We won't hear this, we will hear its effect on the carrier. This has individual wave outputs. This is an aid module plugged in behind the panel to this. This output jack puts any of these out that you want based on this switch and with a volume control. Very convenient. 16-foot level, the first thing you need to do is tune. So, if you haven't already, take your pitch CV into 1 volt per octave. I'm going to use a 4-foot cable because I'm going to go straight to the VCA, the final output VCA. Positive output all the way up, sine wave. Plug into signal input 2 in the VCA and tune. The other thing you can do is hit mute on the Mackie, put it into DP audio track, put in a tuner, and tune it. They need to be really close. Now they are. I unplugged the 4-foot cable, so now the modulator is tuned pretty close to the carrier. Now all you do is you come straight out of the modulator, same jack, positive output, into the control voltage in. I used a 3-foot cable because I know where we're going later. Put this in linear, and then play some notes, just listen to it. Hear all the harmonics coming in, and that's still a sine wave, just being modulated. After you listen to that, put it somewhere high, like about 8, and go back and forth between linear and exponential. So that you hear the difference. That was the demo. Here's the example of the kind of thing I would expect to hear in DP for the capture. Beginnings of bell sounds there. Plenty. For part 3, you're going to leave exactly the same thing you already have. This all the way up, linear. Play a couple of notes, change octaves. You'll notice when you go to low, it goes from audio rate modulation to sub-audio rate modulation, which is what we think of as traditional FM that's not FM digital. But notice also that this modulator is still tracking 1 volt per octave. After you play around with the octaves a little bit, put it back to the original setting, try different waveforms. Square is 50% duty cycle no matter where this is set. Pulse wave is whatever this is at. This is changing the width of that. Now that you've played around with it, here's an example of what I would expect to hear something roughly like this in the capture. Repeat the same moves. Play some notes. Then with the waveforms. Then I ended up back in the same place. So you can hear that was maybe, I don't know, 20 or 30 seconds of me hearing you go to different octaves, then different waveforms, also with the lows so that you're understanding what's happening. Now you're ready to go to part 4. Okay, for the part that adds a VCA in this connection, remember, the amplitude of this signal is called the index. It's the index for the FM. It's going to come into a VCA, and then out of that VCA, right back into where it was. You can use any of the 4, I don't care. Once you do this, have the switch in linear, turn this all the way up and leave this all the way up, because now this initial gain will act the same as that, and any signal you bring into the control input will act as your hand on that knob. Now take another version of your gate output and bring it into the Moon 511. Take the output of that into the control input. Settings I started off with were off, 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 ESUS about halfway or so. None of these matter, and this one all the way up. This knob somewhere between half and full. This one all the way off. This will control the overall intensity of the effect. If you turn this all the way up, this knob now does exactly the same thing as that. The difference is this knob can be modulated with a control voltage. So what you do is you come here to this jack. This is the output of the modulation wheel. If that switch is in mode 3, you feed it in here. This should be all the way up. Now the mod wheel will control the intensity of the effect. Then just do a capture as shown. For part 4, all you're going to do is take this cable, which is feeding the modulator into the carrier, and you're going to put a VCA in the middle so that instead of your hand doing this, an envelope generator will control the level output of a VCA that this is feeding into. So all you do is you take this and you plug it into VCA input. I'm using VCA 1 in the CoreSynth C107. Then you take VCA 1 output right back into the jack you had been using before. Now if you take the initial gain of that VCA and turn it up, it is exactly the same as doing this. So you leave this all the way up, you leave this down. We need an envelope generator. So what I want you to do is come out of your mult for your envelope generator and into the gate input of the Moon C511. It's just above and to the left of the 4-channel VCA. Take the positive output into the CV in. Turn the CV all the way up. Make sure the analog voltage control that's right above the manual gate push button is all the way up. And start off with off, 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 and maybe E-sus, or that's sustained about halfway. If you start turning E-sus, it will be exactly like turning the VCA1 gain or this. It's the volume. So park it about halfway, and you will find that the settings of these 3 controls on this envelope generator are much different than the Q109. Initially, you might not like it till you get used to it. One thing I'll caution you about that might confuse you, the front panel settings for time, they're not even close. So this says 1 second of attack. You can hear as well as I can. It's not well calibrated. So I've got all 4 controls on the envelope generator pointing straight up at noon. Then take the analog voltage control knob above the manual gate red switch and start turning it down. You'll understand that this has exactly the same effect as the CV attenuation on the VCA. The difference is, of course, you can modulate that. Now what I want you to do is make sure on the MIDI interface the mode switch is in position 3. Then come out of the top jack that's right below that mode switch and come into the CV input. Now the mod wheel on the Prophet will control the intensity. So I'm turning the mod wheel on the Prophet up and down. So when you've patched that up and played around with it and listened to it, here's an example of the kind of capture I would expect to hear for part 4. Notice I'm hitting one note over and over and turning the mod wheel. So that's in there. Now during that capture, what I just did is fine. But if you also wanted to add other things, here's an example of somebody who's pushing it a little farther. So this would be an example of part 4 again with the minimum and a little bit more. And it's not about points, it's about whether you're interested in this or not. was part 4. The part adding the sequencer is really simple. Take your row 1 out. If you want to bring it into the switch and have more than 8 stages, go ahead. Come to the quantizer, make sure the switch is set however you want. Take the output into the add input. Now the only other thing you do, right now if you hit play on this, you wouldn't hear anything until you pressed a key on the keyboard, because the keyboard is what's sending the gates. So take this cable and plug it up here. That's it. Now when you hit play, you'll hear it and adjust as shown in the example. For the last required part, all you're going to do is integrate the sequencer very simply. You can use more than one row and use the switch if you want. But at minimum, take row 1. Why not use the quantizer? Come out of the quantizer and into the add input. Now, if I press a key so that the gates are open and hit play, doesn't matter what the notes are, just make something. Then take the gate output of the MIDI interface that the keyboard is sending gates from, unplug it and plug it into the oscillator output of the Q960, hit play. Now you're ready to actually do the example capture. So what you do is play and then manipulate some things. What I'm going to change is the settings on the envelope generator for the modulator, and I'm also going to play with the waveform, the frequency of the modulator, octaves, and also sometimes I'll put the modulator into pulse and then play with the width, including the speed at the same time. That's all I'm adjusting and messing with. Example. So capture some time with you playing around with all that stuff, and then if you want to do anything more for the bonus, here are some ideas for a bonus section. You can do whatever you want. You can use any, all, or none of these ideas. Right now, you've got the 1 volt per octave pitch telling this what to do. If you bring this in here, and out of here into here, now this control will make the pitch glide back and forth between notes. If you're feeling a little braver, you could do exactly the same thing but with far more power. More power. More powerful. By taking this pitch voltage and coming into either the top or bottom half of the dual universal slope generator, or DUSG. Take the DC output, because it's a pitch voltage. Now you have separate control for rise time versus fall time, and you have a control voltage input. So you could take anything you wanted, an LFO, another envelope generator, a row of a sequencer, anything you want into that, and then change how long it's taking to glide up and down to control the pitch of the modulator. Another idea, if you have your modulator in pulse, not square, but pulse, where the width has an effect, you could bring a modulation source into the pulse width modulation input. This is an LFO. If you set this to the lowest speed, roughly about halfway up, the 3 switches all the way up, middle, middle, off, off, middle, middle, all the way up. Come out of the amplitude jack into the pulse width jack. And, this is now going to be changing the pulse width of the square wave. This knob here will control the intensity of it, as will this. You could modulate this. It's got an input to modulate that. Another thing you could do, in addition to this, if you do this, is this will track 1 volt per octave. So if you take your pitch output, pitch CV, and plug it in here, now each individual key will change the speed of the LFO, modulating the pulse width. For the sake of simplicity, I just restored the patch to the way it was. More ideas. What if you wanted to be able to make the sequencer start and stop easily with one switch? There's multiple ways to do it. Here's one. The top of this module, 5 volts is normaled into the input unless you plug something in. So if you turn this up all the way, this is putting out 5 volts all the time. That this switch is in ×1. If you turn the switch up to the top, invert, it then puts out -5. So if you take this and you plug it into the oscillator start, it's going to start. And even if you hit stop, it's going to then immediately keep going until you put the switch in invert. Then -5 comes in here. This is not AC coupled, so this input will see -1 and -5 and -2, all of them as 0 volts. In other words, nothing telling it to play. So if this switch is up and you hit stop, it will stop. So how do you make it start and stop automatically? Take this output right here, come into a mult. Take one output from the mult into the oscillator in. Now what we need to do is take a version of this and invert that, so that when this is at +5, another version's at -5 or 0. And when this is at -5, which means 0, the other one's at +5. So this is a logic block. A and B inputs, 2 blocks. You can use either block, either input. Just for visual confusion, because there's a cable in the way here, I'm going to use one of the lower blocks. Come down here. This is input B, and this is an inversion output. Then you bring this into stage 9. Now, when this switch is up, 0 volts, or the equivalent of 0 volts, comes out and into here. So it's not getting a command to start playing. And then the inverter is flipping it because it's really -5. So +5 comes into stage 9. So it calls stage 9. It stopped when this switch is up. When you bring the switch to the middle, it reverses. 5 volts comes out. The inverted takes it down to -5, which is 0. So stage 9 is no longer being called. And +5 makes the sequencer play. Bottom line, switch up, no play, switch in the middle, play. And every time it will start on stage 1. I'll only throw 1 or 2 more ideas at you, even though there's obviously endless things. Right now, this is the index EG. In other words, the envelope generator controlling the amplitude of the modulator feeding into the carrier. You have one envelope generator. Well, what if you had more than one? So if you took this output here and mixed it, so you brought it into a mixer, and then the output of the mixer back in. Now it's the same patch as it was before if you turn this on and all the way up, and the master volume here is all the way up. But now you have other inputs for other things, like an LFO, a row of a sequencer stage. Or, how about this? What if you take your gate output and you come down into the monostable input of the pulse delay? All this does is it takes a trigger and lets you delay how long it takes before it actually emits it, and you can control the width of it, whether it's short or long. This internally is normaled into a 2-stage envelope generator, attack decay or attack release. So if you take this output, come in here, you can start off by turning this switch off so you're no longer hearing this. Then, every time the sequencer sends a gate, now, folks, use your head. If this is going really fast, the amount of effect you'll be able to get out of this is very limited because there's very short periods of time between each gate. But if you slow this down, you can set an attack, something that just goes or something like that, and then delay how long that takes. So when it fires, then turn on your first envelope and combine the two. So you'll get one envelope and then a delayed one controlling your index. The final idea for you is something that you will see a lot in FM synthesis. You're only looking at a 2-operator system, a carrier and a modulator. But what if you brought in another modulator? We have another pitch voltage here. We could come in here, 1 volt per octave, and then take the sine wave out of this into either this or this. These are both inputs to modulate the frequency at linear or exponential rates with attenuators. So now you've got a modulator stack. You've got modulator, modulating modulator. This is the overall index. Those were a few ideas. You can use any, all, or none. Have fun.